Okay, this is question 14 on the WJC additional maths paper from 2019. So in this question, we need to find, using an algebraic method, the coordinates of the points of intersection of a curve, y equals x squared minus 5x plus 30, and a line, y equals 2x plus 1. So because we've got points, that's a multiple. So essentially what we're going to have is a quadratic, which is going to look like this. And 2x plus 1 is going to look like that. And they are going to cross each other at 2 points. I'd say 2 points purely because we've got points there, not points of intersection. If it was just a point of intersection, it would be a tangent to the curve just at 1 point. Now, whatever happens, if this line and curve meet, at that particular point, they've got the same value of x and the same value of y. And at this particular point, they've got the same value of x and the same value of y. So the y on both curves has to be the same. It has to be equal. So the first thing I can do is I can put these expressions for y equal to each other. So that gives me x squared minus 5x plus 13 equal 2x plus 1. And what we have here is a quadratic. If we have to solve a quadratic, we want to make it equal to 0. So I'm going to get rid of everything from this side. So I'm going to take 2 x's off both sides, and I'm also going to take 1 off both sides. And that will leave me with x squared minus 7x plus 12 equals 0. And we have a quadratic here to Okay, so here's my grid. I'm going to put my x squared term in the top left, my constant term in the bottom right, and these two terms in the middle, they are going to create this negative 7x. So they're going to add together to give negative 7x. Now, in order to find the numbers, we're going to multiply the coefficients of x squared by the constants. So that will give us 12. And I want two numbers that multiply to give 12, so I'll just list them. 1 and 12. 2 and 6, 3 and 4. Now, because they multiply to give a positive number, that can only happen when both numbers in the multiplication are positives or they're both negatives. And because they add to give an overall negative, that can only happen if they've got the same signs, if they're both negatives. So everything in here has to be a negative, and then we're looking for the pair that add up to give negative 7. And that pair is going to be the negative 3, negative 4. So I can fill those in. Negative 3x, negative 4x. And it doesn't matter which way round they are, because if you had the negative 4x there and the negative 3 there, they will still add up to negative 7x. Okay, so let's just get rid of this and start factorising. So I'm looking at the top row, see what comes out as a factor. There's nothing in common with the numbers, but there is an x in both of them. So then I can do x times this value is x squared. Well, that's x times x. And I know x times this value is negative 3x. So that's going to be negative 3. I also know that this value times x will be negative 4x. So that's going to be negative 4. And just to check, negative 4 times negative 3 should give me negative 12. It does. So I'm okay. So now I can solve to find a value for x. So I can rewrite this x squared minus 7x plus 12 as x minus 3 times x minus 4. And that equals 0. So it's the equals 0 that's important, because that now allows us to use a clever little step on the next step and say, well, if we have a product, a multiplication that gives 0, something in that multiplication has to be 0. So either this x minus 3 is 0, so we get 0 multiplied by something, which will give me 0. Or the other part of the product, the x minus 4, is 0. So we'll have something multiplied by 0, which will always give me 0. And if I solve this equation, or these equations, the first one I'm going to add 3 to both sides to give me x is 3. And on the second one, I'm going to add 4 to both sides to get x equals 4. Of the points of intersection. We want the coordinates, so we need the y as well. Now, Now what we do have is an expression for y here and another expression for y there. And we know that y is the same for both of them. So if you substitute your values of x into either one of these, you will get the same values of y coming out. It's easier to use this one because it's a smaller equation. So I'm going to substitute in y equals 2x plus 1. So that will give me y equals 2 lots of 3. So that's 6 plus 1. So that's 7. And on this one, y equals 2 lots of 4, which is 8 plus 1. So that gives us 9. So the points of intersection are, so we put it in coordinate form, 3, 7, because that's what they've asked for, and 4, 9. And that's the question.